All right, this is the last podcast for the 6.2 sequence on constructed types. And we're going to begin, this is going to be fairly short, but we're going to begin with the least helpful, in my opinion, set-wise definition. Starts with the concept. When we talk about functions, right, from a set theory perspective, you got the idea that a set is defined by a collection of a domain, which is the values that something can come from, and a range, which is kind of what it maps to, right? That's the fundamental set theory idea, right? So, and it basically just kind of says, where there's a function, where the domain of that function is the set D, and the range of that function is R. That's it. There's functions are things that take values and yield values. They take stuff and they produce stuff, right? That's all that kind of really means. The concept of a function is pretty universal, right? Interestingly, back in the Pascal days, there were both what we called procedures and functions. And procedures, you had to call, and everything had to go through the parameter list into a procedure. But a function, you could put in line. You could use it like we think of as functions today. And in that environment, because functions were kind of a later concept when compared to the notion of a procedure call. We called it a procedure call. And then C just totally blurred that lines, and there were no procedures, and everything was a function. From a standardized imperative programming language, it was a pretty radical departure from what Pascal had done. And so anyway, everyone's got a function of some form, right? And so in this case, we've got C over here, where we've got clearly what appears to be, I'm taking in a parameter list. Well, in ML, we would say there was a tuple. But in C, effectively it's the same thing, but it's not a type by itself. You know what I mean? It's not a tuple comprised of two characters. It's a parameter list with a character and a character. And maybe that's semantic, but it is really different, right? For example, in ML, where you can actually define a tuple and then just let that tuple be the kind of what the function expects, and then you get all the elements of the tuple, the types of the tuple, kind of for free. And in this case, I'm going to return, I'm going to make a comparison of A equal to B, in the C language, and clearly we look at that and we say, that looks like a Boolean, right? But our function has said, you've got to return an int. So we're going to probably return 1, I think, if that's true, and we're going to return 0 if it's false, and we're going to return that as an integer. Meanwhile, in ML, you notice it's a very similar thing. I'm going to take in two characters, but the function is defined as simply a comparison of A to B. And if you put that into ML, put that into your SML interpreter, it's going to pop out with it'll go char, star, char, arrow, bool. That's what it's going to give you. And the idea is, it's going to basically say it's going to take a tuple of two characters and it's going to return a Boolean. And so again, but everyone's got that idea, and how and it's just an illustration of how different, and what you see in this use of functions. I mean, they're both called functions, but they're just a bunch of assumptions, and it starts to change the paradigm. It starts to change your fundamental assumptions as you do design and things like that, right? So that's kind of the key thing there. The last thing, this is literally the last slide in this relatively short podcast, is what can you do? What are the operations you can perform on a function? And this is I think it's a really critical question, because we know we got to call functions. We got that part. That's what bullet number 1 is trying to say. We call functions, but what else? You think of any other type, and do functions, can we do that? One of the things that in functional programming languages may come as no shock, that there is, this concept of functions as kind of, I think they would refer to them as like first-class citizens. The notion that no, if I can return an integer from a function, I should be able to return a function from a function, right? And I should be able to pass a function in. And we see some of this actually in the homework from, what chapter was it? Chapter 4, where there's a pattern actually that I, 20 years ago, 20 plus years ago, referred to and coined the phrase functional backpack. The idea was that I'm going to hand you a bunch of data, and I'm going to hand you a backpack with what you want to do in it. And it essentially was kind of like a precursor to standard template library and certain kinds of polymorphism. But, to me, the idea was, rather than having to know in my code how to do this thing, I'm just going to hand you the data, and I'm going to hand you the function. And that way I can hand you other data and other functions, but you're always going to do the same thing. It's a certain kind of polymorphism. Well, guess what? A lot of languages, you can't do that. And so just that question, right? Can you pass these things as parameters? Can you bind, can you assign a function to a variable? Can you make that variable equal to a certain function? And what does it mean? What does it mean within the context of the language, right? And again, many languages, most don't support much beyond simply, making a function call. And anyway, we're going to see in ML as we go forward through the semester, what we're going to see is a lot more flexibility, a lot more malleability in what we can do with functions. But again, that is the hallmark of functional programming. That's one of the things that functional programming does so differently than traditional imperative or object-oriented programming. And even if you look at it, differently than, say, Prolog that we're going to get to, ML and other, functional languages, Haskell and Lisp, and others, it really tries to treat functions at every turn like, it's because you have to start by asking the question, if I pass this function as a variable, what would that look like and why would I want to do that? And when you start to just kind of ask that question, then what happens is then your head starts to explode a little bit and you start to realize that there's a lot of concepts and a lot of ideas that become kind of cool and elegant or interesting or easier to understand programmatically when you start to think that way that wasn't native, And what we're going to see, as we talk later, is things like, you take just things like polymorphism, which in ML is almost an afterthought. It's just there. Polymorphism is just there. I define this thing and ML just binds it, figures it out. Go try to do polymorphism in C++. It's a pain in the butt. It's a little bit like doing those union, subtypes, in Ada. I mean, it's a pain, and it makes you do all this stuff. So anyway, you do see a lot more of that functions as first-class values and a lot more things you can do with them in languages like ML. And we'll see that as we go through the semester. That's the rest of the 6.2s. We now have, there are 3 others, and again, I got to look at them and see whether I need to divvy these up, but there are 3 other sections that are coming, which I'll kind of introduce at the beginning of the next podcast.